evening to everyone. Myself Souvik Dutta. Today I will tell about the energy signal and power signal, which will come under the subtopic digital signal processing. So first I will start from the energy signal. So in discrete domain, we will represent the energy signal by E, that is E is equal to summation n is equal to minus infinite to plus infinite mod of xn whole square. Okay, because here n values varies from minus infinity to plus infinity, because n is called the time index whose value is always an integer, and we take n value as 0 plus minus 1 plus minus 2 up to plus minus infinite. In this way we represent the n. So suppose as well as we also in this way also we can represent the power signal in discrete domain. This is the formula for representation of a energy signal. Now I will write the expression for average power of a signal in discrete domain. So we represent the average power by P. P is equal to limit n tends to infinite 1 by 2n plus 1 summation n is equal to minus n to plus n mod of xn whole square. This is the formula for average power of a signal. Now, suppose a signal is given which we is considering xn. Now, we need to understand that when that signal is said to be energy signal as well as when that signal is said to be power signal. Now, a signal is said to be energy signal when energy is equal to some finite value we will get, and for power will be equal to 0. Then a signal is said to be energy signal. Similarly, a signal is said to be power signal when power is equal to finite and energy will be equal to infinite. Now a signal which does not satisfy these two conditions, then that type of signal are said to be neither energy nor a power signal. Now we'll understand this by using or by considering an example. Suppose we are considering a signal xn is equal to 1 by 3 to the power n un. Now it has been asked that find the energy and power of that signal, and from there check whether the signal is a energy signal or power signal. Now for solving that type of numerical, we need to find the energy as well as the average power of the signal, and if we get that energy is equal to finite and power is equal to 0, then the signal is said to be energy signal. If the average power of the signal is finite, energy is equal to infinite, then the signal is said to be power signal. If the signal that does not satisfy these two conditions, then if that condition is not satisfied, then the signal is neither energy nor a power signal. Now the formula already, first I will tell here in xn there is a unit step function is multiplied. Now as we know that if we define the unit step function mathematically, we can write that un is equal to 1 for n greater than is equal to 0 and is equal to 0 for n less than 0. That means unit step function, if we represent unit step function in t domain, that means ut versus t will be look like this. That is, it is only defined for t greater than is equal to 0. This is only defined for in t domain. Now if we define in discrete domain, that is in n domain, that means it will be look like this. That means it is only defined for n is equal to 0 and n greater than 0, and for all the cases the value is 1. It is the unit step function. So this is the mathematical definition of unit step function. Now if we write the formula for energy signal, that is already I have told, that is energy is equal to summation n is equal to 0 to infinite mod of xn square. Why the limit has been changed from? Because already I have defined energy is equal to summation n is equal to minus infinity to plus infinity mod of xn square. This is the original formula for finding the energy of a signal. Now this formula has been changed to summation n is equal to 0 to infinite mod of xn square. Why? Because as there is a unit step function is multiplied with that xn, with that 1 by 3 to the power n, there is a existence of unit step function. So obviously the for minus infinity to minus 1, the unit step function value will be 0. So that's why the n limit has been changed from n is equal to 0 to infinite mod of xn square. Now if we write this, then we will get summation n is equal to 0 to infinite 1 by 9 to the power n. Okay, because 1 by 3 to the power 2n, then after that simplification we will get 1 by 9 to the power n. Now after that if we solve it, so from there we can write this is a infinite GP series. So we know that the formula for infinite GP series, that is 1 plus x square plus x cube plus up to infinite, the infinite GP series formula, that is 1 by x 1 minus x, provided x is less than 1. Same formula will apply here. That means from there we can write 1 by 1 minus 1 by 9, that is 9 by 8 after simplification. So here we are getting energy is equal to finite, that is 9 by 8. Now after that we need to find the value of power. So already I have written the formula for power. So I will again write that expression. So here again the limit was from minus n to plus n. It has been changed for to 0 to n, because minus n minus n to minus 1, the value of unit step function is 0, because unit step function is only defined at the right hand side of xy plane. So that's why the negative values of n, the unit step function value will be 0. So that's why the limit has been changed from n is equal to summation limit has been changed to n is equal to 0 to n. So after that if we put the xn value here, so we will get limit n tends to infinite n is equal to 0 to n 1 by 9 to the power n. Now after that if we write the formula for finite GP series, so from there we can write limit n tends to infinite 1 by 2n plus 1 into 1 minus 1 by 9 to the power n plus 1 divided by 1 minus 1 by 9. So this is the result we will get. And why n plus 1 term is coming? Because here it is going from n is equal to 0 to n. So from n is equal to 0 to n, there will be n plus 1 number of terms will come. So that's why I have written n plus 1. So here n tends to infinite means 1 by infinite, that means 0. So here finally we are getting energy is equal to 9 by 8 and power is equal to 0. So here energy is finite and power is equal to 0. So that's why that type of signal are called the energy signal. Now we will solve another one numerical, another different types of numerical, which is also asked that check whether that signal is energy signal or power signal. Okay, that is xn is given e to the power j pi by 2n plus pi by 4. Now it has been asked that check whether this signal is a energy signal or power signal. Now for that, first we need to find the value of energy. Already we know the formula for energy, that is E is equal to summation n is equal to minus infinite to plus infinite mod of xn square. Now if we take the mod value of this, that is mod of e to the power j pi by 2n plus pi by 4. So we know that mod of e to the power j theta, if we take, that is mod of, if we break it and simplify it, we can write cos square theta plus sin square theta, because e to the power j theta is cos theta plus j sin theta, and from there if we take the modulus, then it will be root over of cos square theta plus sin square theta, that is 1. Same concept will be applied here, that is it is given e to the power j pi by 2n plus pi by 4. That means if we break it, we will get it cos of pi by 2n plus cos theta, that is cos pi by 2n plus pi by 4 plus j sin pi by 2n plus pi by 4. And after that, if you take the modulus, then you will get, that is cos square pi by 2n plus pi by 4 plus sin square pi by 2n plus pi by 4. From there, we will get that modulus of this value is 1. That means if we find the energy, that is E is equal to summation n is equal to minus infinity to plus infinity mod of xn square, that is 1. So from there, that we, here we are adding 1 infinite times. That means suppose it is given that n is equal to minus 3 to 3, summation n is equal to minus 3 to 3 1. That means from there we can, how many sample points we will get, minus 3 minus 2 minus 1 0 1 2 3. That means 7 sample points are there. Similarly, if we take n is equal to minus 2 to 2, summation n is equal to minus 2 to 2 summation 1. Similarly, here we will get the 5 sample points. Here we will get the 7, here we will get the 5, because minus 2 minus 1 0 1 2. So 5 sample points we will get. Similarly here, that is n is equal to minus infinity to plus infinity. So here we will get 2 into infinite plus 1, that is infinite points we will get. So from there we can tell that energy will be equal to infinite. Okay. Now if we find the power of that signal, so what will be the value of the power? Limit n tends to infinite 1 by 2n plus 1 summation n is equal to minus n to plus n mod of xn square, that is 1. So limit n tends to infinite 1 by 2n plus 1 into, look here, here summation n is equal to minus n to plus n summation of 1s. Here what we are getting, n is equal to minus 3 to 3 1. So that means here we are getting 2 into 3 plus 1, that is 7 sample points we are getting. Similarly here, minus 2 to 2 summation 1, that is 2 into 2 plus 1, that is 5 sample points we are getting. Similarly here, energy, that is minus infinity to infinity 1, that is 2 into infinite plus 1, that is infinite sample points we are getting. That's why energy is equal to infinite. Here similarly here, summation n is equal to minus n to plus n 1, that means here we will get 2n plus 1 points we will get. So 2n plus 1, 12 plus 1 will cancel each other. So we will get finally the power is equal to 1. Average power of the signal is equal to 1. So here we are getting energy is equal to infinite and power is equal to finite. So that type of signal is said to be power signal. Now the signals which that does not satisfy, for that, suppose if there are any signals is there, for that energy is equal to infinite and energy is not energy is equal to suppose in infinite and as well as power is also infinite, then that signal is said to be neither energy nor power signal. Now, if we solve another one numerical, xn is given, suppose sine pi by 4n, and it has been asked that find energy and power of that signal. So, from that expression, we can find that here, if we solve the numerical, here we will get energy will be equal to infinite. We will get if we solve this numerical, and power is equal to we will get some finite power value we will find if we solve the numerical. So this type of signal are called that it is a here we will get the average power is equal to finite. So this type of signal is called the power signal. Okay. So in the next day I will, or in the next class I will tell about the periodic signal and aperiodic signal. So thank you.